Okay, hello students. Here, if you see this, this is lesson number 7, and in the lesson 7 is we should be able to create polynomials given the factors and the zeros. So the learning target is write some polynomials. I can write an expression for a function that has horizontal intercepts. So I'm gonna straight away solve problem uh, uh, practice problem for lesson number 7, and here it is the first one. So the first question is a student by name Diego write this expression as an example of a function whose graph has x-intercepts -4 and 2. What does it mean is, so there is a graph here, 2, 3, 4, -4. So these are the points where the graph crosses the x-axis. And because there are two factors, so he thinks like as if there is a graph or something like this. Uh, Again goes to 2 and then goes to -4, and you can see there are these x intercepts are 2, so he writes this. So where is his fault? uh, if this is the, let's see, if these are the x's, if he knows that the graph crosses at -4 and +2, that means x equals -4 is one factor and x equals 2, right? And if you add 4, both sides you get this crosses, I get x plus 4 equals 0, and the other one, if you subtract this both sides you get x minus 2 equals 0. That means x plus 4 is one factor, and if you can multiply this and create a polynomial, x plus 4 and x minus 2 equals 0, and that is f of x. So what mistake he did is he took exactly the same -4 right here and the same positive right here. So that is the mistake that he has made. So he should have switched the sign of the -4 and +2 and make it +4 here. So that is the mistake. Okay, let's go to the second question. In this question, you see that you're supposed to write an equation for a polynomial. So write a possible equation for a polynomial. It means we need to write something like this. And because there are three of them, so I'll have three parentheses, okay, and put x and x and x. And because the horizontal intercepts are these, so what is that basically means is the graph crosses 1, 2. So that's the 1, 2 is minus half. So if this is -1, that will be minus half. And that's -3, -2, and -3. So these are the three places the graph crosses. So these are the x horizontal x-intercept. In other words, there are three of them, right? So that means you're going to have a degree 3 because there are three maximum uh, solutions or x horizontal intercepts. So that means the graph could be down up. So it goes this way, okay, and then goes this way. So it is down up. But the question is not about to create the to sketch the graph. You just want to create the equation. So all you do is if it is 2 here plus 2, you just put a -2 here. If there is a minus half here, then you put plus half. Okay, and if this is -3, then you put opposite is +3, and you're done. So that's all it is. Write a polynomial equation. But we could also write this. This part we could easily change. Now, what that means is x plus 2. If you don't want to keep a fraction, I multiply 2 over 2. So that way you have a denominator 2 and it has 2x plus 1. And that could be written as exactly x minus 2, and the second one is x plus 3, and this will be 2x plus 1, and this 2 could be written outside here 1 over 2, and you're done. So this is also correct, equivalent polynomial function, which is a cubic polynomial because it has degree 3. There are 3x when you multiply these. When you multiply x, if you plug in x equals 0 there, if I plug in x equals 0, 0, 0, all you have this is you multiply the the number by itself, and that is That is minus 2 times half times this is 3 and this crosses out, so you get minus 3. And that's what this means is basically the graph crosses the y-axis at minus 3. So this is like a minus 3 because this is also a vertical intercept. So I'm gonna, even though this question was not asked, but I will let you, it's better to know what is the vertical intercept, means where does the graph crosses the y-axis, and this is minus 3. It is also constant here. So when you plug in the x equals 0, that's what you get, and I hope that makes sense. And these are the horizontal intercepts right here. They are the horizontal intercepts, this one. Okay? They are also called zeros. So we also say zeros. When you write zeros, you don't have to put x. You just put 2 minus half and minus. These are the zeros. If you want to write the solution, so sometimes you want to know what is the solution of the equation. Suppose I want to put the polynomial equal to 0. So when is this whole polynomial will be 0, then we say solution set or two values, and that is put the braces and you say, okay, it's uh, it's 2 minus half and minus, so the same thing, but put in the braces. That's called a solution. Okay, let's move to the third question. Now, this question only is asking is write a polynomial function for the graph. So you are given the graph is down, up, right? So that means the degree will be always either 1 or 3 or 5 odd numbers. Okay. And to create, we just have to write, let's call this as gx. And because there are three of them, see negative 4, negative. So you have the horizontal intercepts of x-intercepts are negative 4, negative 1, and these are also solution. But if you want to write solution, you put braces. But if you want to say zeros, then you just write minus 4, minus 1, and 3. Or they are also x-intercepts. Now, if this is odd, you have to put three factors and put x, x, and x, and then write the opposite of this. So opposite of minus 4 is plus 4, opposite of minus 1 is plus 1, and opposite of 3 is minus 3, and you're done. And then one more question is, what does this number means? It means if I plug in x equals 0, when the x coordinate is 0, then you will see everything, this will be 0, x is 0, and uh, and this plus 4 remains, plus 4 plus 1 minus 3, and you just have to multiply this 4 times 1 times negative 3, and that becomes negative 12, and you'll see this is negative 12. So that's the meaning of vertical intercept, or it is also called y-intercept. So this is also y-intercept. And you can see there's also very soon you'll see the behavior. What is the end behavior of this graph? If you see this, as you go on increasing the x very large positive number like this, the y coordinates, this graph will go up plus infinity. And the same thing if you go to the left side, when x will become very large negative values, the graph goes down. So it means the y coordinate going on become very large negative number. You can see, so something like this. So we say minus infinity. Or there is also the range of the polynomial function is from minus infinity to plus infinity as x, and the domain is, you can plug in anything here, x value. So the domain is also all real numbers. Let's check problem number 4. Okay, this question is asking which expression is exactly the same. Is this the one? Is this the one? Is this the? So all you do is actually you can use either FOIL method or you can use the box method. I'll do the box method because this is like 3x. I'll put 3x plus 2 is like the length of the rectangle here. See, and this part is like 3x minus 5 is the width of the rectangle. So all you do is you want to write this instead of uh, multiplying two binomials, I want to split into four rectangles. So when you multiply the first two, so this rectangle and this length with 3x and 3x will give you 9x squared. Then this one and this will give you 3x and 2 will give you, so you're going across, right? So you're multiplying, the first time you're multiplying 3x to the top, uh, 3x plus 2. So 3x first is done, and then this and this is 6x. Now I'm going to use different color to show. This time we are using this rule. So this one and this one will give you negative 15 because negative 5 and 3x will be negative, sorry, uh, negative 15x. And then this one and this will give you negative 10x, right? So negative 10. And then you try to put this together because these are like terms. So 9x square remains. So 9x square will remain. This together will be, this is plus 6x and that's minus 15. So you subtract and you get minus 9x. And this remains by itself the number. And you can see it is the this part, right? And you get the answer. And this is quadratic. Okay, just wanted to show a lot of information of quadratic function is the degree here. Quadratic polynomial is what you're supposed to remember. The degree is the highest, largest exponent, which is 2. The leading term is the one that has the degree. So the whole leading term is 9x squared, this whole thing. But the 9 has a special name for it, and it's a leading coefficient. Okay, so leading coefficient, it's positive. So the graph is something, sorry, the graph is up, up. So if you want to sketch this graph this way, say, and they gave us this one, if you try to do where does the graph crosses? You can just put x equals, opposite of plus 2 is minus 2, and then this divide by 3, and that's the one. The other one is you see opposite of minus 5 is 5, divide by 2. So this is where the graph crosses, the maybe here and maybe here, and minus 10 maybe here, and the graph goes through minus 10 here, and this is like minus 2/3, and this is 5/3, something like that. So this is a parabola which opens up because it's positive here. So hope that helps. So let's go to the next. In this question, what is the value of this whole thing? All you do is supposed to just plug this in. I can call this as f of polynomial f of x and plug in x as minus 3. So that all you do is write the same thing. So everything stays the same. Okay, so this is minus 2. All you do is just plug in the number minus 3. So this minus 3 I'll put here, minus 3, minus 3, and then you just figure out what is the value. That's all it is. It means for x input, x coordinate, minus 3, what is the output? We want to know what is the output. So this will work out to be negative 5. This will work out to be negative 6. This will be negative 5. And this will be negative 8, right? So when you multiply this 6, you multiply this 2, then you multiply this 3 and see what you get. If I multiply this 2, I think it become minus 30, 6 times negative 5, 30, and then you multiply minus 6 will give you 0, 1, and minus 80. And likewise, you work out this and then figure it out by yourself. In this question, they are just asking us, what is the leading coefficient? All you do to know the leading coefficient is you have to multiply this, this, and this. That's all it is. If I multiply x and 2x and 4x, you can see there are 3x multiplied itself, so it is x cubed, and 2 times 4 is 8. So that's the leading coefficient. So where is this leading coefficient? You can see this one is here. So the leading coefficient is the number or the coefficient of the leading term. This whole thing is the leading term. So the number multiplies to x is the coefficient, and that's the leading coefficient. What changes from A to B? There's a half. Everything is the same. So this part is the same. This part is the same. All you do is multiply by half. That means the answer that we got here, 8x cubed. So when you work this out, let's say this when you work out, maybe starting will be 8x cubed. and there will be some number and x square, there will be some number x, and there will be some number, right? So this is the so what's happening right now here is you are multiplying this whole thing by this half, see? So that half. So when you multiply, it distributes to everything. So this half time 8x cubed. See? So this is the leading term, and what is half of 8 is 4x cubed. And that's how we say the leading term now is 4, and you get the answer. The other one, the C, just the 5 is multiplied. That means instead of half, we are multiplying by 5. So that means 5 8s are 40x cubed, then 5 times whatever that is, and blah blah blah. But this is the 40. So where is the 40? So this connects here, right? The next one is, and there's a minus. So all you do is just multiply minus here outside. Okay, so multiplying minus 1 here. So minus 1 times this will be minus 8x cubed. So this becomes the leading term. So this will go here. Okay. And I hope you're understanding what I'm saying is. And the last one is 1/4. So what is 1/4 of this? So that means so this is the original one, and now you multiply by 1/4 to the whole thing. So 1/4 of 8 x cubed, which is 2x cubes. So the number is 2. That's the leading term, and you get this answer. Okay, and this is how you do. Let's do the next. So I'm gonna go for lesson number 8. So this lesson number 8 is about uh, uh, so if you check this, the learning target is to know the end behavior of the polynomial function. So how does the graph behaves when if you see this part, there's a square, there's a cube, there's 4. How does the graph look like? There's an activity here, but I'm gonna go directly and solve the practice problem to help you to understand better. So the first one, here it is. This is practice problem lesson number 8. And what are you supposed to do here is what are the end behavior of this? So how does this graph look like? Now, first of all, remember this is a uh, polynomial function of degree, and the degree is 3, right? So when the degree is 3, which is the largest exponent, it, and that's the odd number. And if you see on Friday, I try to show how do we know how does the graph look when it is the degree 1 or 3 and 5 and 7. So if it is 1, I remember the degree, see it was a line. If it is 3, it is down up. So it's always down up like this. If it is 5, it goes this way. See, so it takes 1, 2, 3, 4 turns. If it is 7, it becomes like this. So there will be 6 turns, 1, 2. So this is how the behavior of so it's like suppose I do this way. It means as the x increases, as x becomes very large positive number, the y goes on increasing to plus infinity, and that's what that means. So I'm gonna go directly and answer the question to the first one. So you know it is a cubic polynomial. You know the degree is 3 and it is odd, so it has to be down up. So what are you supposed to write for the first one is it is degree 3. So if this is x-axis, and I don't know where the graph crosses that, but at the most it may look like this. Uh, Let me write another one, another very nice, beautiful. So see guys, so like this. It means what this basically means is when you make x very, very large positive number, let's say if I write 10, 20, 30, 40, 50, 100, 800, 1000, 10,000, maybe and like that. So x goes very large positive infinity. Then this y value, see, this point will always have any x coordinate will always will have y coordinate So as x becomes very large positive, so it means 10,000, 10,000, 100,000, million and all that. And then y value goes on increasing, so gaining height here. See, they go on in gaining height like this. So that means the y value becomes very, very large positive infinity. So that's all it means. And similarly as x, if you make very large negative, like let's say minus 100, minus 1000, and then you go minus, and so on, and I say 1 million maybe like this, but negative, very large. So when x goes, what is this basically means? When x takes very large negative numbers, so large negative numbers, large negative number. What that means is that x goes to almost like minus infinity, and the y goes down. Can you see? So these are like minus 10, minus 100, minus 1000, minus and so on. So this graph which goes down, the y coordinate of each point of the, see the y coordinate is become very large negative number, and it's a minus infinity. So this is the understanding of cubic polynomial. Hope I made sense to you. The second question, there is a plus x square means it's a, you see there's a 2 here, that means the degree is 2, and the degree is 2 is a parabola. Like, see, of course, there is a plus sign, you see the parabola opens out. If this was minus, then it would be some looking like this down, down. So you have to be very careful here if it is positive and negative. Positive always, for degree 2, even number, it's up, and I don't know where exactly it crosses, but looks like there is a plus one here, so it is crossing somewhere here, and maybe both are negative, something like this. Maybe I'm just, so all basically it means is it goes up. It means when x is very large. So what did we understand here is when you take x as very large positive value, the y coordinate goes on increasing to plus very large positive value. So for x very large positive value, the y also become very large positive. But on the left side, if you take x very large negative number, then the y also, that's the end behavior. The y also goes up, see, up, and this is also up. So up basically means the y coordinate also becomes very large positive number, that is plus infinity. And this is because it is even. Now this could have been also if the degree is, let's say, 4, and I could have just created another anything like this, 4 minus 2x cubed plus 4x minus 9, and say this is a degree this. So this graph will look like, and we have seen this on right some WC. So whenever there is a degree 4, 2 and 4 and 6 and 8, it's always up, up. All it means is on either side, when you take x, very large positive numbers, x, or very large negative number, the y value will always become plus infinity. So it goes up, up. That's all it means. We could show also, I could make another polynomial with degree, let's say 6. So all I will have to do is, I'll have to do is add one more here, see, plus maybe 3x raised to 5 and plus 2x raised to 6. So then it will look like it takes 5 turns, see. So it's like 1, 2, 3, 4, 5, and there will be at the most maximum 5 places. Sorry, 5. 1, 2, 3. I think I made a mistake here. Let me do it one more time. So I have to go. So if this is the case, then the graph goes like this. If you see, now it will be 4, but then I have to take one more turn. So 1, 2, 3, 4, 5, 6 maximum, and it goes up and it goes up like this. That's it. So just wanted to show that how does the graph behave is for degree 6 is when x becomes very large positive number, the y value, the output become very large positive infinity, and if x is very large negative infinity, then the output become very large. Both sides positive infinity positive. And this question, see, is straight away degrees 4. I already explained to you. So something like this. So both sides, when x is very large, positive infinity or negative infinity, it is up, up. It means plus infinity and plus infinity this side. What does this mean? The degree is 1. It's a line, see? It's the line which is rising up, something like this. So down, so on the left side, when x is very large negative number, so it is minus infinity. It means it goes down, see, minus infinity. So when x is very large negative number, the y value takes very large negative. And if you take x is very large positive number, then this line rises up. So it means its y coordinate also goes very large positive infinity. So let's go to the next question. And this question is asking to check if a student knows which polynomial, there are four of them, which one among them gets larger and larger in the negative direction. So in the negative direction means here, this is the negative direction, right? Negative, so down, down, as x becomes larger and larger in the negative direction. So I want you to understand what does this means. Means x becomes very large. It means if this is x-axis and the y-axis, all they're asking us is when x is very large, so when x takes very large, so the side going very large negative number, then which of the graph goes to down? That's all they're asking you. Now remember, this is 2 and this is 4 and this is 6. But by just looking at this graph will look something like this. It is a parabola, goes up. This will be like a W shape, again up, up. And this also will be like a W, extended W shape, so both. So the only one left is this, there is a cube here. So what does that cube means is the graph is this way. So it is like when x so it is like down, up. So what is that down, up means? So it goes down to minus infinity. So as x becomes very large negative number, the y will become very large negative number. So that's the answer to be understood. So it's a cubic polynomial of degree 3. It is down, up because it's plus 6 here. Just imagine if it was like, I'm just showing if this was minus 6x cubed like this and something like this. So this time you are taking a minus. So this will be just the opposite of that. That means the sketch will look different. And it will start from top like this and goes like this. See? So it starts up and then down. So this will be just opposite of the earlier one as x becomes very large negative, larger and larger negative number. And then this will be very large positive number. So you have to be careful there. So let's go to the next. Watch this graph. You just have to identify what do you think will be the degree of this polynomial. Look at this. It is up, right? It's going up, and it is W shape. So it will have four factors like this. Okay, and you can clearly see it crosses -2 means +2, -1 means +1. Just do the opposite, and this will be -1 here because it's +1. So this will be -1 and this will be -2. So this is degree 4. So you're multiplying x and x and x and x. So 4 of them when you multiply itself, you get degree 4, x raised to 4. So that's the degree, right? So that's all they're asking if a student can identify what could be the degree of this polynomial. And you can see it is the, of course, they are not asking the end behavior. They are only asking what is the degree. This question is similar to the earlier one that we have. You want to make a open box with the corners 22 and suppose there is a box like this which is 22 and 28 and you want to cut off a square with side length x. So that means you get a box something like this. Okay, you get a box. So like this. So that means you are cutting off x here. So it is from 22 you have to take away 2x and from 28 you take away 2x and the height is x. So length with height will be the so this will be 22 minus 2x, this will be 28 minus 2x and the x. So that's the expression for the volume of the box. And if it is 6, you plug in 6 and get the answer. I want you to do this. And what is the reasonable domain? This is where everybody gets confused, but still one more time I would like to share that the domain means how much maximum can you cut off. Among the length given is 22 and 20, this is the smaller one. That means I can cut at the most halfway down, that is 11, right? So you can cut, of course, it has to be something, so it is greater than 10. At the same time, it should be half of this 22, and half of 22 is 11. So then only you can have a box. Otherwise, there won't be any box formed. So that's what that means. This is a very interesting question. They're asking you write in the standard form. So all I would do is I'll do this first. Okay. So let's work out this, and you can make a box like this quickly. And then I can write x and 2, then, sorry, and x and plus 2. So all you do is multiply x, and x is x squared. This x and this 2 will be 2x. This plus 2 and this x will be 2x. And this 2 and that 2 will be plus, I think it is minus 3 here. I'm sorry. This is minus 3. See, this is minus 3. So this become minus 3x here. Yeah, let me write neatly here. It means this is minus 3. So this become minus 3x. Okay, and this is plus 2. So this is plus 2. So 2 times this 2 and this when you multiply become, and then combine this. So all you get is 3x plus 1, and then you put this here, x squared. This together is minus x because subtract when you get minus, and this minus x. So this is what you get. And the next step is all you do is make another box. This time a longer one because you have x squared. So I put here this minus here, this will minus 6, and this 3x here, and again do the same thing. So multiply this 3x to x squared, so that becomes 3x cubed, and the same minus 3x to this one will be minus 3x squared. The same minus plus 3x to this will be minus 8x. Okay. And then now you multiply 1, so 1 times this will be 1x squared, then again 1 times minus x is minus x, and again this to minus 6 will be minus 6. Then we combine the like terms. So these are the like terms. So, and then these are the like terms. So your final product is, this stays the same. So this f of x becomes equal, this stays, so 3x cubed. And this black color together will be minus 4x squared. And the pink color will be minus 19x and minus 6, and you're done. So this is all it is. In the second question is, all you do is multiply by 2. So whatever that, this one, so if I want to know what is this change, you just make a video, one second. Finish it, please. So just multiply this minus 2 to all of them. So minus 2, so 3x cubed minus 4x squared minus 19x and minus 6. So all you do is multiply this, and we use the distributive property. So minus 2 and 3 will be minus 6x cubed, minus 2 and that will be plus 8x squared, and this will be my plus 38x, and the other one will be plus 2, and you're done. So this is an example. He writes this as an example for a function whose graph. Remember when I did the same thing. His mistake here was, what mistake does he do is he should be taking the opposite, right? When you write this, he has to write the opposite of the x. Right? If it is minus 3, put plus 3. If it is minus 7 and plus. So that's the mistake the Kiran did in making this equation. Okay, so with this, I'm ending the question, practice problem lesson number 7 and 8, but just want to make sure, wind up this. What I'm trying to say is creating a polynomial is main thing. If I have just wanted to show x intercepts is minus 3 and plus 2, is basically, it means it goes through minus 3 and plus 2, the graph. And if you multiply, it becomes minus 6, maybe minus 6. So this is the two places where the graph crosses the x-axis, and it's a parabola, something like this maybe. and then cross is also minus 6, and so the horizontal intercept becomes vertical intercept is minus 6, and the horizontal intercepts are, you have to write minus 3 0 and 2 0. These are called horizontal intercept. And when you write it, you can say, okay, these are x intercepts. Okay. And the zeros are, so when you write 0, it is minus 3 and plus 2. So as I'm saying, like these are x-intercept. When you write like this horizontal intercept, these are the zeros with the number. And if it is asked solution of the equation, polynomial equation, then you write braces and you say, okay, minus 3 and 2 like this. Hope that helps. And one more thing is take away from these two lessons is the and behavior of the polynomial. And we have seen on Friday how they look, right? So we have seen that uh, so for linear, if it is 2x plus 3, it is a line. If it is 3x squared minus 5, it is a parabola. If it is x cubed plus 7x plus 2, it's going to be down up. And if it is x raised to 4 minus 5x squared and minus 7, there's a degree 4. So it is something like this.